This video shows how to construct a perpendicular bisector of a line segment. So a perpendicular bisector is a line that cuts a line segment into half at a right angle. So we're supposed to get a line that cuts through this line into half at a right angle using a compass. So to construct a perpendicular bisector, first place the sharp tip of the compass at one of the points. Open up the compass to more than half of the line so that you're able to get a perpendicular bisector. So first I place the sharp tip at point A. Then next, draw an arc on both sides of the line. Try to draw as long as possible so that you don't have to go back and draw the second time. Okay, then place the compass at the other point without changing the radius of the compass. And draw an arc that intersects the arcs that you have drawn just now. So notice that the arcs drawn form two intersection points, and when we join these two intersection points with a straight line, you actually get the perpendicular bisector. Therefore, this is your perpendicular bisector. To check that it is accurate, you can use a protractor to measure the angle that is formed by the perpendicular bisector and your line. So this angle here should be 90 degrees. And based on the measurement, it is 90 degrees. You can also check that you have cut the line into half. So from point A to this point should have the same length as from this point to point B. Mark the intersection point here with a right angle, and these two are equal lengths. Do take note that for perpendicular bisector, any point along the perpendicular bisector is equidistant from points A and B. For example, let's say if I select a point here, if I were to measure the distance from this point A to the point that I've selected, let's let this point be X. If we were to measure the length from A to X, which is about 4.9 cm, notice that when you measure the length from X to B, it is also 4.9 cm. So this is what we mean by equidistant. X is a point along the perpendicular bisector such that it has equal distance from A and B. You can also observe an interesting property that since we have two lines of equal length, AXB is actually an isosceles triangle, such that this angle and this angle are the same because these two lengths are the same. And the perpendicular bisector actually forms a height, the perpendicular height in the triangle itself. So this is what you need to know for perpendicular bisectors. The second part of this video is on the second part of geometrical constructions on constructing an angle bisector. So previously we bisected a line segment into half at a right angle, so this is called perpendicular bisector. In an angle bisector, we are cutting an angle into half, again with the use of a compass. So let's say I want to bisect the angle ABC. Notice that this angle is formed by the lines AB and BC. So we're going to use these lines to help us construct that angle bisector. Using a compass, open up the compass to this length. It doesn't have to be very long as you can draw your angle bisector. Place the sharp tip at the angle that you are bisecting. Next, draw an arc on the lines that form this angle. So we make a mark here as well as a mark here. Again, it doesn't have to be very long. Do take note that while doing this, the radius of the compass should not change. Next, place the compass on the point that you have marked out on each of the lines. So let's start with this one first. Draw an arc on this side of the angle. And our aim is actually to have arcs that form an intersection point so that when we draw from the intersection point to the angle, you constructed your angle bisector. So notice that while drawing this arc, the radius of the compass doesn't change. Next, do the same thing. Place the compass at this point and draw an arc that passes through the previous arc that you have drawn. And now you can use a ruler to connect the intersection point to the angle that you are bisecting. Do take note that the angle bisector should exceed the triangle. And therefore this is your angle bisector. To check the accuracy of an angle bisector, you can use a protractor to measure the angle that you have cut into half. So therefore, this angle should have the same number of degrees as this angle here. So using a protractor, this angle is about 28 degrees. Let's measure the other side of the angle. And using a protractor, it is also 28 degrees, hence this angle bisector is accurate and he has cut the angle into half. A property of angle bisector is such that any point along the angle bisector is equidistant from the lines that form the angle that you have bisected. So what do I mean? The distance from, for example, let's let this point be x. The distance from this point to AB, the perpendicular distance, should be the same as the perpendicular distance from this point to the line BC. So let's try and measure the distance from the point X to each of the lines AB and BC. So draw a perpendicular line from X to the line AB, and using a ruler to measure, this is about 2.3 cm. And when measuring the perpendicular distance from this point to BC, it should be the same. Since the line BC is not long enough, we can actually extend it slightly. And the perpendicular distance is from here to here. Using a ruler to measure, this length is also 2.3 cm. So this is what I mean by having equidistance of this point to the line AB as well as from here to the line BC. So therefore, we have just tried to show that this point is equidistant, in other words, equal distance from this point to AB as well as from this point to BC. So this is the property of an angle bisector. To understand why using a compass actually helps us to construct this angle bisector, you might want to know that what we have done throughout the whole process. Notice that while constructing an angle bisector, we marked out two lengths of this size on AB as well as BC, and they are the same. So let's mark that out so it's easier to see. Okay, then what we did next was, from this point, we actually tried to draw another line of the same size over here. So from this point to this point is actually the same length. And we also did the same from here to here. So in other words, we have also formed another line. And therefore, this is actually a rhombus, such that if you remember, in a rhombus, all four lines have equal length. And in this case, this line is parallel to this line, and this line is parallel to this line. Recall the properties of a rhombus. The diagonal of a rhombus, meaning from one point to the other, actually bisects the angle. So in other words, this line here, the diagonal of the rhombus, will cut each of these angles into half. Therefore, this is why constructing a rhombus unknowingly actually helps you to construct your angle bisector.